Okay, in this lecture video, we're going to go through the guidelines for drawing Lewis dot structures of molecules or compounds that have covalent bonds. So there's also a handout available on the Unit 1 module of the Canvas page that will take you through this as well. The example that we're going to use is ammonia, which is the chemical formula NH3. And if you look on the periodic table to get the electron configuration, you'll find that it's 1s2, 2s2, 2p3. So our valence level is n equals 2. We know that at n equals 2 we have, oops, I forgot my s. We have only an s and p orbital. Those are the, s and p subshell. Those are the only two that exist. So that means that this subshell needs 8 valence electrons to complete it. And right now, if we look at how many we have 2 in the S subshell and 3 in the P. That's 5 valence electrons. That's for nitrogen. And we know that the hydrogen atom, again, is just a 1s1. So it's going to need 2 valence electrons total to complete its n equals 1 subshell, which is only an S subshell. So let's go through the things. The first one that we do is we're going to add up all the valence electrons in our structure. So for nitrogen, if you look on the periodic table, nitrogen has 5 valence electrons. We also added those up from our electron configuration. Hydrogen, we said, has 1 valence electron, but there are 3 hydrogens in our molecular formula, so that's a total of 3 valence electrons. So there are a total of 8 valence electrons that we need to show on our Lewis dot structure. The second step we do is we divide the valence electrons by 2. And the reason why we do that is we're going to put them onto our structure in groups of 2. So we're going to work with them in pairs. And those pairs that we're going to show either going to be shown as bonds between atoms, or those pairs will show up on a single atom. And when they show up on a single atom, we call them a lone pair of electrons. Okay, so if we take 8 valence electrons and we divide it by 2, that tells us we have 4 pairs of electrons to put on our Lewis dot structure. The third step that we make is we're going to arrange our atoms symmetrically about the central atom. That means you have to figure out which one the central atom is. And there are a few guidelines for that on the worksheet, or excuse me, the handout that I have. First of all, we know that hydrogen can never be in the middle, and that's because hydrogen will only form one bond because it only needs 1 electron to complete its valence shell. So the middle atom is never hydrogen. The middle atom is often first in the formula. It's another way to identify it. So typically we try and write formulas in the order that to show the bonding. Or in this class, if I think it's too hard to figure out what the central atom is with some simple guidelines, I'm just going to underline it for you so that you know, and you can learn in a different class how you really go through the process to figure it out. So in the formula NH3, which is the one that we're working on, we know hydrogen can't be in the center. That means it must be nitrogen. List here. So arrange atoms around central and attach. And you're going to attach in the beginning with just a single bond. I'm going to write my nitrogen here, and I'm going to surround it by my 3 hydrogen atoms symmetrically. And you might choose to arrange these atoms around the nitrogen separate or in a different way, and that's okay, because remember, it's just a model. So once you arrange them, you attach them then with a single bond. Okay, so we can add that. Okay, so the next step then that we're going to do with our structure is we're going to add the remaining pairs of electrons that we haven't used yet. And we're going to do that in a way to complete the valence shell on each particular atom. Okay, so we had, according to step 2, we had 4 pairs of electrons. And in our structure so far, we have used 1, 2, 3 pairs. So that means we have 1 electron pair left to place, and we need to place it in a way that we fill the valence shells. So now we need to see who doesn't have a complete valence shell. So if we check our hydrogens, we see that each one of these hydrogen atoms, because it's formed a covalent bond, has access to the 2 electrons in that covalent bond. So its energy level, n equals 1, its valence shell is filled. It only needs 2, because that's all that's in that energy level is an S subshell. But if we look at nitrogen, our nitrogen only has access to 2, 4, 6 electrons. So that means that that final electron pair has to be given to the nitrogen in order to complete its valence level. And we show that as a lone pair of electrons. So there are a lot of ways that in this final structure. So I could write it like this. Or you might have arranged your atoms in a different way. You could write it like this. Or maybe you wrote it like this. That's fine too, and I could keep going with all the different combinations to arrange these atoms around the central atom. But they're all correct because what's important is we've shown which atoms are bonded to which atoms and where the lone pairs of electrons are. So let's just do one more example here to take us through the steps. And that example that we'll do is formaldehyde, which is H2CO. So I'm going to underline here the central atom, which is carbon. Okay, so our first step was to add up the valence electrons. So we have 2 hydrogens, and each hydrogen has 1 valence electron. We have 1 carbon, which has 4 valence electrons, and we have 1 oxygen, which has 6 valence electrons. So this is from the hydrogens, this is from the carbons, this is from the oxygens. So if you add that up, you get a total of 12 valence electrons. And if you divide that by 2, that means we have 6 pairs to put on our structure. Take a look. The next step that we do then is we're going to arrange our atoms symmetrically about the central atom. And again, you could arrange them symmetrically in a different way. We're going to connect them all by a single bond. So there's a bond, there's a bond, there's a bond. And at this point, we had 6 pairs to start with, minus 3 pairs. That leaves us 3 pairs of electrons to put on our structure. So if we look at our structure, we know that hydrogen is done, right? Each hydrogen has formed its 1 bond that it needs. Carbon has 2, 4, 6 electrons available. So I could give 1 pair of electrons to it. That leaves me with 2 pairs. Then I could give the other 2 pairs to oxygen. But if I do that and we count up how many electrons oxygen has, it has access to 2, 4, 6. So when I put those 3 pairs on and added them all as lone pairs, I wasn't able to complete the valence level, which is energy level 2, which needs 8 electrons in its shell. I wasn't able to finish that for oxygen. It's still only got 6. So this structure is not going to work. So if I go back to where I left off, which looked like this, instead of placing a lone pair on the carbon atom to complete its octet, I'm going to place a second bond to oxygen so that oxygen has more access. So that was 1 pair, 2 pairs, 3 pairs. And now, if we add up the electrons, we have 2, 4, 6, 8 electrons available for the carbon, and we have 2, 4, 6, 8 electrons available to the oxygen. So they've both completed their outer valence shell. It's now full. And then if we go ahead and double check to make sure all of our 6 electron pairs are shown, we've got 1, 2, 3, 4, 5, 6. So all of our electron pairs from the valence shells of all the atoms are now represented on our structure.